Okay, so I said this problem would take a little bit of work, so I did a lot of work before the video started just to make it easier on you guys. So really fast, I calculated all the side lengths. So the green one, notice how we have 8 to 4. Alright, so that's dividing by 2. Alright, and then there is a little bit of work I put left on this. Alright, I calculated Z, which was, this yellow side, so like AB right here, was the square root of 40. Plugging that into a calculator gives me about 6.3. And then over here, on the other triangle, I called this side X. That was the square root of 10, which plugging into a calculator is 3.16. That was 6.32. There is some rounding going on, but yes, overall, that's again dividing by 2. Alright, the bigger triangle has to be divided by 2 to get to the smaller triangle, and then the last side, let's just confirm that works. Alright, this side right here I called Y, and again I used the Pythagorean theorem to find these side lengths. A squared plus B squared equals C squared. Square root of 72 is about 8.48. And over here I called this side W. The square root of 18 was 4.24, which again, divide by 2. So the triangles are oriented differently, but all the corresponding side lengths are proportional, so they are similar. Alright, so that's how that works. That one was yes. You could take a screen or pause the video if you want to actually work it out, or you can just accept these numbers as fact, and believe me, that's cool with me. Same thing in this bottom one, or same concept. I counted really fast, 4, 8. Those were the corresponding sides, so I'm multiplying by 2. I got the square root of 5 for this side right here. What is the square root of 5? Well, that was 2.23. And over here, this is exactly 5. I can do Pythagorean theorem shortcut. That's not multiplying by 2. Alright? Not times 2. So it's not the same scale factor for all sides. So the sides aren't proportional. Triangles are not similar. Okay. Whew. Those were two doozies of a problem. Did a lot of work off screen for you guys. Moving right along. Alright. Remember, sides are proportional. Angles congruent. Alright. So we're actually going to go depth in the next coming videos on this stuff, but this is 72, this is 72, this is 18, this is 18. We actually have enough information now. We can say yes, they are similar. You just need 2 angles, but we know all 3 angles are congruent, so yes, the triangles themselves will have to be congruent. All angles are congruent. Alright? So same thing, same concept going right here. This is some action-packed stuff. So basically in that last one we just counted the angles really fast. Well, look right here. OMG, what do we got? We got some vertical angles. Alright, these are vertical angles. We know that they're congruent. Alright, really fast right here. Notice how this is a slope of 1, up 1 over 1, up 1 over 1. Then we have a slope of -1, nice, negative, nice, negative. So those lines are perpendicular. Opposite reciprocals, we got perpendicular lines. Same thing down here. The nice, negative, nice, negative. So we know that that's congruent. Then by process of elimination, we know 2 angles. So we know the third angles are congruent as well. And we're actually going to go a little bit more in depth than that. But since these 2 triangles, all angles are congruent, that's a side effect of similarity. So yes, they are similar. Woo! Action-packed stuff. Alright, now And this one right here, we got triangle BAC is similar to triangle DEF. All right. If AB is 5, ED is 2, and FD is 3, we need to find CB. All right. So they're not drawn to scale. So this is a little awkward. I think I know what's going on, but let's just be careful on some stuff. Let's look at this. We want to find CB. Notice how C and B are the first and last letters in the similarity statement. What about D and F? All right. Same thing, all right? They're the last letters. All right. So it's all about matching up corresponding parts. There's a few different variations of this ratio I could draw. All right. Just one of them I can say, well, 5 over CB. All right. Well, what corresponds to 5AB corresponds to ED. So I can say 5 over CB equals 2 over 3. All right. That's legal. I'm allowed to set that up. I could have also said 5 over 2 equals CB over 3, so on and so forth. Regardless, cross multiply, 15 equals 2 times CB. Divide both sides by 2. CB equals 7.5. Boom. Right there. Nice. All right. Question 10 of 16. ABCD, the squiggly line, FGHIJ. Those two polygons are similar. All right. Which of the following statements is false? So we got a lot to go through. All right. Which one of them are false? Well, let's just start knocking out some easy stuff. I feel like angles are always easier. E and J are the last letters. I know E is 63. So J also must be 63 degrees. So D is actually true. All right. Now, matching up some corresponding parts. GF is telling me to find the length of GF. Well, notice GF corresponds to AB. All right. Also, we have BC and HG are corresponding as well. All right. So setting up some things, I can say, well, 8 over GF is equal to 7 over 2. Cross multiplying, we're going to get 6 equals GF times 7. Divide both sides by 7. GF equals 16 over 7. So that one's also true. Okay. What is the false one? JF. Let's look at JF. All right. JF is right here. JF corresponds to AE. All right, so I'm going to say 14 over JF. And let's just stick with this ratio, 7 over 2. That was nice. We already found that one. 7 over 2. So we'll use it again. 28, 7 times JF. And we can quickly see that JF is going to be 4. So I found A, B, D all to be true, so I guess JI will be the false one. I'm not even going to spend time to calculate it. It has to be it. It's the only one left. Process of elimination.